Hi guys, welcome back here to section 3.4. We're going to be solving exponential equations first and then moving on to some log equations. So for example, number 1, we've got a property that says if I've got an equation where the bases are the same, then the exponents have to be the same. X has to be equal to y. And that only works if the bases are the same. Alright, so for an A, I can't say anything about this until I've got the bases the same. Luckily, we know 36 is 6 squared. So this guy's really 6 squared to the x plus 1. There I've got 6 to the x plus 6. When I raise a power to a higher power, we multiply our exponents. So this is 6 to the 2 times x, which is 2x. 2 times 1 is 2. And now I've got my bases the same. I can say 2x plus 2 is equal to x plus 6. And now that I've got it out of the exponent, I can solve this like any other linear equation. Subtract x, I get x. Subtract 2. 6 minus 2 would be 4. And there's my solution. All right, moving on to B. I've got 1/2, and I have got 64. And so the best place to have like a common meeting ground between those two guys would be 2. So I know that 1/2 is 2 to the negative 1 power. And I know 64 is 2 to the 6th power. Again, multiplying my exponents here, I've got 2 to the negative c is 2 to the 6 times 1/2 is 3. So negative c is equal to 3. So c is equal to negative 3. All right, you try, same thing. I've got 16, which I know is 4 squared. If I wanted to, I could take this all the way down to 2's, but they both share 4 as a base. So this would be 4 to the 2x plus 2 times 3 would be 6. 4 raised to the 4x plus 7 power. So 2x plus 6 is going to be equal to 4x plus 7. Subtracting 2x, I get 2x. Subtracting 7, 6 minus 7 is negative 1. Dividing by 2, I get x is equal to negative 1/2. All right, for B, B is a little tricky. I call it my pre-AP problem, right? How do I get 2/3 to be 9/4? Well, I see this correlation here. I know 2 squared would be 4 and 3 squared would be 9. So I guess I could say this is the same thing as 3/2 squared raised to the 3x plus 4, but that doesn't really help us much because I need the 3 to be down here and the 2 to be up there. And so what would flip my fraction? And hopefully you said, well, Miss Harris, if you want it to be 2/3, you got to raise that to a negative 2 power. Remember that negative changes which side of the fraction the number lives on. So then this would be 2/3 to the x minus 5 power. This guy would be 2/3 to the negative 2 times 3 would be negative 6x. 4 times 1 would be 4. That guy reduces down to negative 3/2 x. All right. And so then we know x minus 5 is equal to negative 3/2 x. All right. Something feels weird here because I don't remember doing some fraction math on this problem. So let me go back and see what I'm doing wrong. Nope, maybe it's right. Okay, sorry. I thought, I don't remember this from the other day. Well, that's okay, I'm old, so I don't remember everything. All right, so if I move the x over, I've got negative 3/2 plus 2 more halves. This would be negative 5/2 x. To get rid of this negative 5/2, I'm going to multiply by negative 2/5. When I multiply this guy by negative 2/5, my 5's cancel. Negative times negative makes this positive 2. This seems a little different from what I did the other day. So if you remember and you can come tell me what I'm doing funky, I might give you some candy or something. I don't know. All right, but the answer is 2. So I got there in the end, but there might be a quicker way of doing that one, and I'm just not seeing it when I'm this close to the board. All right, example number 2. Now we've got logarithmic equations as opposed to exponential equations. So we know that I've got log base A of x equal to y. Then if I want to go into exponential form, this would be a to the y is equal to the x. In other words, the base of my log is the base of my exponent. Raised to this exponent is equal to the argument. So think of a counterclockwise circle from a. So this guy here is really log base e of x is equal to 6. So this would be e to the 6 is equal to x. And so you just plug e to the 6 into your calculator. And your calculator will tell you that's about 403.43. All right, for B, before I can put things into exponential form so I can solve it, first I gotta get this log by itself. So I'm gonna subtract 6. I get 2 log 5x is equal to 18 minus 6, which is 12. Dividing by 2, I get log 5x is equal to 12 divided by 2 is 6. Now what's the base of this? That is common log, right? So common log is base 10. 10 to the 6th power. 10 to the 6th power is equal to 5x. I'll divide by 5. So what I'm putting into my calculator is 10 to the 6th divided by 5, which is 200,000. And since it's exactly 200,000, I can write an equal sign instead of an approximation. All right, for C, I've got 8 to the 12 is equal to x cubed. And then I would take the cube root of this guy, and I get x is approximately, exactly equal to 4096. And that's one way you could do the problem. And then some people were saying, why don't we use that power rule, which I think is great that you've learned it already. I could say that's 3 log base 8 of x is equal to 12. And then divide off the 3, and I get log base 8 of x is equal to 4. And then putting in exponential form, x to the 4th is equal to 8. And so x is equal to 4096. It does not matter which way you solve these problems. Sometimes there's 3 or 4 different ways you can solve them. And it's good math to be able to do it more than one way. All right, so for A, I'm going to go ahead and divide by -3. I get natural log of x is equal to -24 divided by -3 is 8. Remember, the base of this guy is e to the 8 is equal to x. So x is approximately equal to, 2981 is what the book says, but it says in the instructions to round to the nearest hundred. So if that's what it says in the instructions, that's what you want to do. I want to say this one was 2980.9 something or 8 something, 7 something, somewhere in that ballpark. So make sure you follow the instructions on your quiz or your test, but that's the example that was in the book. All right, for B, again, got to get that log by itself first. So subtract 4. 16 minus 4 would be 12. Dividing off that -3, I get log of 5x. 12 divided by -3 is -4. So 10 to the -4 is equal to 5x. Why 10? Because this is common log. We don't write it, but that's log base 10. And so dividing off 5, this time you either get 1 over 50,000 or your calculator will spit out 0.00002. All right, and finally for C, I've got 3 to the 4th is equal to x squared minus 1. That means 81 is equal to x squared minus 1. Adding 1 to both sides, you get 82 is equal to x squared. Taking the square root, I've got x is equal to plus or minus. Don't forget, square roots, any even root, it's going to be a plus or minus. Square root of 82. You might see it like that. You also might see plus or minus 9.06. All right, that's it for example number 2. Come back and we'll do 3 and 4.